All right, what's up, guys? Mr. Jones here, and we are going to be going over some literal equations, okay? Some specific types of literal equations. So first off, what a literal equation is just, it's an equation that has more than one type of variable or letter in it, okay? And that makes it a little bit different of how we solve the equation, and it's going to make our answer especially look very different than a normal equation that we would solve, right? An example of a normal equation that we would solve would be like 4x minus 1 equals 11, right? And we could, right, you see there's only one type of letter in here. There's an x, right? And that's different from these that have an x and a y, right? But we learned these, right? So you solve by, right, adding 1 to both sides, and 4x equals 12, and then dividing by 4, right? So if you're asked to solve this for x, your goal is to get the x by itself. But what happens here on the right side is that these can simplify, right? We can do 11 plus 1 is 12, and then 12 divided by 4 is 3, right? And so that's, again, how we would solve a normal linear equation, okay? But these literal equations, again, with more than one letter in here, we're going to be, our answer especially is going to be a little bit different than a problem like this, okay? So let's just do one at a time, okay? And I'll try to go slowly here. We'll do 4 examples, and then that'll be it, okay? So this one says solve the equations for y, okay? So first off, the directions are going to tell you, okay? When it says solve for y, you know what your answer should look like. It should be y equals, and then whatever else ends up here on the right side, okay? Again, that equal sign serves as kind of a barrier that breaks up your two sides. And so we just want y all by itself over here, and then every other term ends up on this other side, this right side, okay? And so what does that mean for solving, right? Well, you look at this side and you think, okay, what are the other terms that are over here with the y, right? Because I want that to be by itself. And so the other term that's over here is this 1x, okay? And so with literal equations, I said it's different, but the rules for, like, you have to do something to both sides, you use the opposite to cancel, right? There's the rules to solve an equation. They stay the same, but just mainly the answer is going to look very different, okay? So if I want this y by itself, I have to cancel out this positive 1x, right? And it doesn't usually write the 1, but we know that's 1x. And so I think, okay, if that's positive 1x being added to the y, how can I cancel that? And I have to cancel that by subtracting, right? Because 1x minus 1x would be 0x, and that would successfully cancel it from this side, okay? But I can't just cancel stuff, right, just wherever. I have to do that rule where I do it once to both sides, okay? And so what I'm left with down here on this next step is going to be, on this side is just y, and that's what I wanted, right? I wanted y to be by itself, which it is now. That's awesome, okay? But this side is where this is where it's different, right? In a normal equation, we could just do like 11 plus 1 equals 12 and combine those, okay? And what a lot of kids do, a lot of kids make the mistake of saying, okay, 10 minus 1x is 9x, and they say that, okay? But that is not correct, and I hope you see why, okay? Why that's not correct. This 10 does not have an x with it, okay? And so that means that we call this 10 a constant, okay? Constant means it doesn't have a variable with it, and that is just like a set number. It's 10, okay? Whereas this minus 1x, okay, that's not a constant. I would call this a variable term, meaning it can change depending on what the value of x is. And again, I don't know that right now. But so basically, these are two different types of terms, two different types of numbers. And when I have two different types of things, I can't really combine them. I can't do 10 minus 1x to get just like a single term or a single number, okay? So I have to leave these as separate because it's kind of like two things that don't mix together, two things that don't combine. So this is as simply as I can write it, 10 minus 1x, just writing it straight up as it shows here, right? So that's my final answer. My final answer is y equals 10 minus 1x, okay? Because the y is by itself, so I know I did solve for y. But again, I'm not going to find a single number answer with these two different types of letters in here, okay? Now that might be super weird, okay? But again, you'll see that that's kind of how it's going to be here for these types of problems, okay? I'm going to do number 2, and like I said, I'll do a couple more. And then hopefully by the end of it, it'll make a little bit more sense. So looking at number 2 here, x minus 3y equals negative 9. And again, directions are the same. Solve this for y. Okay. So if I take that, again, remember your goal. Your goal is to have the equation be y equals, and then everything else is on this right side. Okay. Doesn't matter how ugly this right side ends up being, right? Because it's usually going to be more than one term with these literal equations. But that's okay. Once the y is by itself, you're finished. This right side can be super ugly, and that's okay. So, but you think about the same thing. You think, okay, I want to get this y by itself. How do I cancel out these other terms and numbers that are not a y? And so again, you're usually going to add or subtract first, okay? And so when I have this 1x, and this is really tricky, okay? You might look at this 1x and see, oh, that's being subtracted. So I have to add 1x to both sides. And that's a very common mistake. Here's why that wouldn't work, okay? Because this is positive 1x, right? You don't see a negative out in front of it, okay? So if I did 1x plus 1x, I would actually end up with 2x, right? If I added 1x plus 1x, I would get 2x. So that won't work. Again, I want it to be canceled. I want it to be 0x, okay? And so even though this sign tells you how it's subtracted to the y, or how it's connected to the y, we look at the sign before the term to tell you whether you're going to add or subtract that, okay? So this is 1x, okay? And so I would minus 1x because I want it to be 0, right? And so 1 minus 1 is 0, and that's canceled, okay? And so I have to minus 1x over here as well, okay? But you might be saying, okay, well, what about that minus, okay? And that minus, this is something new with algebra, okay, that you deal with in a lot of different algebra problems. This subtraction sign, I like to think of it more as just a negative, okay? Like this is saying negative 3y, okay? And you're kind of combining this positive 1x and negative 3y, okay? And that might take some getting used to, but yeah, but when you bring this down, it stays as minus or negative 3y, okay? So that minus goes with the 3y, this 1x is kind of apart from that. Anyway, so then again, this on this right side here, negative 9 minus 1x, okay, again, if this had an x with it, I could combine them to get a single term. But this doesn't have an x, which again makes this a constant minus a variable, and I can't combine those. So I have to leave them separate. So negative 9 minus 1x. And so that's what I'm left with right now, okay? And you look at this and you think, okay, am I finished? No, you're not, just because this y is not by itself yet totally. I have to cancel out this negative 3, okay? And the negative 3 is being multiplied, right? This is saying negative 3 times y, right? And so I have to cancel that by doing the opposite of multiplication, which is division. I divide both sides by the negative 3, and then the y is by itself. Great. But then again, I have to do that same thing. And when I divide something, I divide everything on this side by a negative 3, okay? You could write it as one big fraction, okay? But I prefer it as the two separate ones. Each term over here is being divided by that negative 3, okay? And so then I actually do the division, right? Because negative 9 divided by negative 3, right? These are both constants, okay? And even if they weren't both, I could still do negative 9 divided by negative 3 to get positive 3, okay? So this first division ends up with a positive 3, okay? But then look at this. Negative 1x divided by negative 3. But you can still do a negative, because this is negative 1 divided by a negative 3, right? A negative divided by negative I could write as a positive. So you could write this two different ways, okay? This 1/3 x is the same as this, or you could just write it how it was and say 3 plus 1x over 3. These two things are equal to each other, okay? So anyway, either one of these is okay. So that is the first two examples, okay? Hopefully I know it's really weird and tricky, but hopefully you're starting to get the idea a little bit. Let me do two more for you here, and then hopefully by the end, you'll be at least a little bit confident with it, okay? All right, we're back here, and I got 3 and 4, okay? We're gonna go through these the same way, okay? And the direction stayed the same. Solve the equations for y, okay? So again, your goal stays the same. You want y to be by itself at the end. All the other terms on the right side, okay? So again, you're gonna notice a pattern with these, okay? Like for number 3, okay, you see this x term, and then this y term equals the constant, okay? And there's a reason, let me just tell you, there's a reason we're doing these problems that all look similar. Okay, there's a lot of different types of literal equations that don't look exactly like these, but these all follow a pattern. And the reason we're doing all these similar ones is because this is going to really help you with something we're going to do in Unit 2, okay, when we start graphing lines, okay? So that's the reason I'm doing all these like this, okay? Anyway, but there's a pattern. That's what's nice. There's a pattern, right? The steps that you follow are similar because these equations are so similar, okay? So anyway, you look at this, okay? And again, I'm going to cancel out this x term, okay? So I have this positive 8x, and it's being added to the 2y, okay? So it's positive 8, right? No negative sign out here. So I minus 8x from this side to cancel that, okay? But again, I have to do the same thing over here. So I'm left with 2y equals 10x, right? 18 minus 8 is 10. No, don't do that. That is wrong. Okay, I do that sometimes in class to try to see if kids are following. You don't do that. Okay, you can't combine these because this doesn't have an x. Okay, so again, constant minus a variable you can't combine, so you leave them separate as 18 minus 8x. Even though it's tempting, I know you see the number minus the number and you want to combine those, but again, when it has an x with it, can't do it. And then again, I want y by itself, and I'm almost there. I have to cancel out this 2 coefficient, and so I divide that, okay, because it's being multiplied, so I cancel it with division. And again, not just the 18 divided by 2, both of them. Both of them are divided by 2, okay? And so after I do that, I divide these, okay, 2 separate divisions here. So I do 18 divided by 2 is 9, okay? And then again, negative 8x divided by 2. And again, with addition or subtraction, I can't combine at all, okay? I can't combine these at all. But with multiplication and division, okay, because really, even though the 8x, these are like together, okay, remember, they're being multiplied, so they're kind of separate from each other, okay? And so negative 8 times x over 2, I can still divide this negative 8 by 2 while still leaving the x kind of separate, right? Because I can't do x divided by 2. I don't know what x is. But I can do negative 8 divided by 2, and that would be negative 4. Okay. But the x kind of stays there. X stays separate. So I can divide by a number even though this has a letter with it. I just can't add or subtract. Okay. So I know that's a weird rule too. But I'm done here. I'm done here. Y is by itself. So y equals 9 minus 4x would be that answer, okay? Last one here, number 4. Number 4 says 7x minus y equals 3, okay? So again, a similar type of problem, okay? And I'm going to start this one out the same way. This positive 7x, I would not add it to both sides, even though there's a minus here. That minus goes with this y, okay? I look at in front of it, right? And that tells me it's positive 7x. So positive 7x I have to subtract or minus from both sides, okay? Because 7 minus 7 is 0. 7 plus 7 would be 14. That means it's not canceled. So I minus 7x from both sides. And so this would be not just y, right? This minus goes with it. So really this is saying negative 1y. That's how I would write that, okay? This is minus, and this is just 1y. So I do like writing the 1 in there because that reminds you that, oh, I have another number here to cancel out. So after that, I'm left with 3 minus 7x, right, leaving these separate. And then here, this negative 1, I would divide it because it's being multiplied by y. So cancel that with division. You're going to have to divide both of these by that negative 1, okay? So it's canceled here, and I'm left with y equals 3 divided by negative 1, okay? Dividing by 1 doesn't change the number, but it does, right? Because it's negative, it changes the sign. So this would be negative 3. And then negative 7x divided by negative 1. Again, it's not going to change a whole lot, but because it's a negative divided by a negative, I would write plus 7x. So there we go. That's that. Okay, so a weird topic here. I hope that at least makes a little bit of sense. I have another video of this going over it a little bit more simply if you want another explanation of this, but hope that's helpful. Thanks for following.